Under 2.5, we are going to discuss about the discriminant. And discriminant is part of the quadratic formula, and we are going to understand more about it in this video. So if you square any real number, the result is greater than or equals to 0. So this means if y is negative, if y happens to be negative, then the root of y, it does not exist. The root of y does not exist simply because we have no roots of negative numbers. If y happens to be negative, then we have no root y. But I want us to watch very closely to the quadratic formula that suggests that x is equals to minus b plus and minus b squared minus 4ac everything over 2a. And I want to highlight this part as the discriminant in the quadratic formula. And I want everybody to understand that the nature of the discriminant determines the roots of a quadratic function. What nature are we talking about? So if the discriminant happens to be greater than 0, then we expect two distinct roots. I will explain something here. If the discriminant, which is b squared minus 4ac, happens to be greater than 0, then that particular function, or rather quadratic function or quadratic equation, it has two distinct roots. Meaning that because the discriminant is greater than 0, that means it is positive, and we know the square root of any positive number is plus or minus a. So when it is plus a, it gives you a specific root. When it is minus a, it gives you a specific root. That is why we have two distinct roots. When the discriminant is exactly equals to 0, then the quadratic equation has one repeated root. If it is equals to 0, then the square root of 0 is simply 0, and there are no two numbers, there are no options to work out with. So whatever root we will get that is the root of that particular quadratic function, because discriminant itself is 0, and we all know that the square root of 0 is 0. So the root becomes minus b over 2a. That is just but the root. But if the discriminant is less than 0, then it means therefore we have no roots. That it has no root. Some books will say no solutions. That particular quadratic equation has no solutions, simply because we have explained this earlier. We do not have any square root of a negative number. Please note that when any number is less than 0, it must be negative number. And of course, we have just said it over here, when we have y being negative, then the root of y does not exist, simply because we have no roots of negative numbers. So when the discriminant is less than 0, obviously it's a negative number whose roots do not exist. And that is why the quadratic equation does not have solutions. If I may want to sketch diagrammatically something like this, when we are having now a quadratic graph that looks like this, of course we have, this is x1 and x2, we have root 1 and we have the second root, then the discriminant here is greater than 0. You can see we have two distinct roots. That is case 1. Let us look at case 2. In case 2, if we have a graph that looks like this, please note it just touches the x-axis and leaves just one point, whereby we have x1, and that is the only root. Then we have one solution, and this is actually case 2. That means we have only one repeated root. You have only one possible value of the root of that particular quadratic functions. Let's look at case 3. The case 3. Case 3 is something that looks like this. Please note that it does not anywhere touch the x-axis. It doesn't touch or meet the x-axis at any point. That means the fact that it doesn't touch the x-axis, it means the graph doesn't meet the x-axis, and therefore we have no solutions. Remember, in a previous video, we said that the solutions or the roots of any quadratic functions, when it is represented graphically, are the x value when the graph cuts the x-axis. The x-axis intercept gives you the solutions or the roots of that particular quadratic function. And now that in case 3 here, the graph does not touch the x-axis anywhere, then we have, this one talks about we have no solutions. This one talks about we have no solution. This is one repeated solution, and these are two distinct roots. Of course, please know this is case number 1, this is case number 2, and this is case number 3, as highlighted in some information that are after there. Please note that the nature of the discriminant, I repeat again, determines the nature of the solutions of any given quadratic functions. All right?